Hello, this is page 107, the homework from last night from Graphing Quadratic Functions, worksheet number 7. So we want to identify the vertex. The first thing is we're subtracting 2, so that just goes down 2. There's our vertex. And when I pattern graph, it's going to pattern graph as 1, 3, 5 because there's a 1 out front. So from my vertex, I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, so on and so forth. There's our parabola. Next problem. Because this is in parentheses, that means it's going to shift left. That's the x direction, so I get negative 2, 0. There's my vertex here. My pattern graph is going to be 1, 3, 5 because there's a 1, 3, 5, or 1 out front of the parentheses. So I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. And here's our parabola. Problem number 3, this is going to do two things. This is going to have it go left. So in the x direction, it's going to go left. It's positive. And when it's in parentheses, it's always opposite sign. Outside means it's going to go up 2. So I'm going to get right 3, up 2. There's my parabola. There's a 1 out in front of that, so it's going to pattern graph as 1, 3, 5. So right 1, up 1, left 1, up 1, right 1, up 3, left 1, up 3. And go ahead and make your parabola. Problem number 4, this is going to, because that's a negative 4, shift right 4. Because that's a negative, it's going to go down 5. There's my vertex, so 4, negative 5 is down here. Our pattern graph is still going to be 1, 3, 5 because there's a 1 in front. Right 1, up 1, left 1, up 1, right 1, up 3, left 1, up 3. We have enough information to get a nice parabola. Number 5. Okay, so this is going to go left 1, but there's nothing here. So that's just going to be 0. So negative 1, 0 is here. Our pattern graph now is going to be 3 times 1, 3, 5. So that's 3, 9, 15. And we don't use all of the numbers, but we use a couple of them. So let's see, I'm going to go right 1 up 3, left 1 up 3 from our vertex. I don't think I can go 9 more up. 9 more up would be up here someplace. So we'd have enough information to say this is a nice parabola. Problem number 6. This right here is going to have a vertex at 3 because I'm adding 5. Parabola, our vertex is at 3, 5. Because we have this negative out front, it's going to go down. So it's going to be negative 2 times 1, 3, 5. So that's negative 2, negative 6, negative 10. So from our vertex, we're going to go right 1 down 2, left 1 down 2. We can probably do a little bit more. Go 6, right 1 down 6, left 1 down 6. And there's our nice parabola. Okay, that takes care of the homework. I need you to go to page 109 in your book, page 109. All right, so we're going to go review the 3 different ways that we have graphed. This is standard form. This is the first one we had done. So the first thing we had done is we we have a equals 1 because there's 1 out front, b equals 6, c equals 5. I'm then going to go x equals negative b over 2a, and that's going to find us our axis of symmetry. So I get negative 6 over 2 times 1, which is going to be negative 3. That's our x value. Remember that x value, the axis of symmetry, is always the x value of our vertex. So next I'm going to take this negative 3, I'm going to plug it in right here. I'm also going to take that negative 3 and I'm going to plug it into both my x's up here. So make sure you put it in parentheses when you're plugging things in. That way you can keep the right sign. So that's going to give me 9 minus 18 plus 5. If I do the math there, that's going to give me negative 9. That's going to give me positive 6. So, did I do that right? Oh, I made a mistake. I'm sorry. So that's going to give me negative 9. Negative 9 plus 5 is negative 4. Boy, I sure did make a mistake. Sorry about that. We don't know the y-intercept yet, but our pattern graph is going to pattern graph as 1, 3, 5 because our a value is 1. So right one up 1, left one up 1, right one up 3. So it's going to give us, those are both roots. That's a root and that's a root. So we can answer this question. So it looks like that's going to be at negative 1 comma 0 and negative 5 comma 0. And I'm going to go one more. I'm going to go out to the 5. So right one up 5, 4, 5, and left one up 5. So that's going to be our y-intercept. Y-intercept. So that's going to be the point 0 comma 5. And now we can draw our parabola. That's the first method that you'll see. We'll have a test on Friday. We'll give you the take-home test that we'll work on this coming week. This is our second method. Remember, these are going to give us roots. So that's going to give me 3 comma 0, because it's always opposite when you're pulling it out of a parentheses. And that's going to give me negative 1 comma 0. So let's go ahead and plot those 2 points. So 3 comma 0 there, negative 1 comma 0 is there. Halfway in between those looks like right here. So my axis of symmetry is x equals 1. We know that our axis of symmetry and our vertex share the x component. Then I'm going to take that 1 and plug it in. I'll plug it in here and here. Keep the negative 2. So negative 2 times 1 minus 3, 1 plus 1. So negative 2, that's going to give me negative 2. That's going to give me positive 2. Negative 2 times negative 2 is positive 4. Positive 4 times 2 is 8. So I get to 1 comma 8, which is way up here. If we wanted to pattern graph this, which we could, because that's going to give us the y-intercept is going to be negative 2 times 1, 3, 5. So that's negative 2, negative 6, negative 10. And we'll probably only need this one to get our y-intercept. So I'm going to go right one down 2, left one down 2. And so that's the y-intercept. This is a root because it's crossing the x-axis. This is a root because it's crossing the x-axis. And we're going to go ahead and draw in our parabola. Our y-intercept would have been 0 comma 6 because we had said it was right here. That's the y-intercept. Okay, method 3 is the one we just learned. Okay, so let's find our vertex first. So this is going to give me positive 2 because it's always opposite when it's grouped. This is going to give me positive 1. We know the axis of symmetry and the x value are going to be the same, so we can go ahead and draw that in. So the axis of symmetry is at 2, so it's coming straight down here. I know we weren't drawing this yesterday in the homework, but for the test we're going to probably have to do that. We're just going to make our vertex at 2 comma 1, which is right here. Our pattern graph is going to graph at negative 1, 3, 5. So negative 1, negative 3, negative 5. So let's go ahead and pattern graph that. So I'm going to go right one down 1. Oh, it's hitting the x-axis. That's a root. So that's 3, 0, which is a root. I don't know if it's going to ask for the roots or not. Oh, it sure is. So this is a root, and this is also a root, 1 comma 0, and 3 comma 0. We don't quite know the y-intercept yet, but our pattern graph was going to keep going. So I'm going to go down, right one down 3, and left one down 3. And now we have our y-intercept. Right there's our y-intercept because that's where it's crossing the y-axis, which is going to be the point 0 comma negative 3. And we're going to pattern graph off this. And that's all we have. This is kind of fun. So let's think about our equation, which is y equals a x minus h quantity squared plus k. That's our vertex form general equation. So take a look. Our vertex right here is going to be 1, 2, 3, 4. So it's 4, negative 1. So this is my x value, which is my h. This is my y value, which is the k value. We're going to plug those in. So I'm going to get y equals a times, when I plug it back into the parentheses, it's going to change the sign here. So that's going to become a negative 4 squared. And then this right here is going to just stay negative 1. Now, how we find the a value is, think about how we pattern graph. If I pattern graph, if I go right 1, up 1, I go left 1, up 1, that means my a value has to be 1. So I'm going to make this a 1, x minus 4 quantity squared minus 1. So my vertex form is y equals, I don't have to have this 1 out front, so I'll just leave it just like this. And if I wanted to change this to standard form, and I don't know if we're going to test on this or not, but this means I'm going to multiply this whole thing out. So I have x minus 4, I have two of them because it's squared, and then minus 1. So let's going to multiply this out. I get x squared minus 4x plus 16 minus 1. So our standard form is going to be y equals x squared minus 8x plus 15. So this is the standard form equation. And again, I'm not sure if we're going to test on that or not, but it's okay if we're going over a few. Here's another one we were going to remember, and I'll give you this equation to make sure you have it if it is on the test on Friday next week. All right, so our vertex is going to be negative 2, and then looks like negative 2 comma 4. So this is my h value, my x value, and this is my k value. We're going to plug those in, so I'm going to get y equals a x. Remember when I plug the negative 2 in, I'm just going to change the sign, and then plus k, which in this case is 4. Let's look at our pattern graph. If I were from here, if I went right 1, down 1, 2, I get to another point. So I'm going down 2. So that, because I'm going down this 2, this means my a value has to be negative 2. So we can go ahead and plug that in. X plus 2 plus 4. All right, that's my vertex form. And then if I wanted to find my standard form, I'm going to multiply that whole thing out. So I'm going to bring it over here. So I have negative 2. I have x plus 2 quantity squared, so I have 2 of these. And then plus 4. We're going to multiply these out real quick. So the negative 2 is still there. X times x is x squared. Plus 2x gives me plus 4x. Times 2 is plus 4. And then plus 4. I want to distribute over, so there's a little bit more work, but it's still, I think, easier to do if you follow the routines. And plus 4, we're going to combine those like terms together, so I'm going to get y equals negative 2x squared minus 8x minus 4. Okay, so our homework for tonight, and what we'll do is, why don't we make this due on Tuesday, so we'll go over more of it on Monday, but it'll be due Tuesday next week, and I'd like you to do page 111, 112, and that would be, let's go ahead and do 1 through 12, all of them, okay? Um, we're now going to watch a video in class, um, and it's a goofy video. It's a video that my friend of mine and I had made many years ago. It's really bad how it's done, but what we were doing is collecting data, and it's just something to show how the parabola works with the braking distance of a motorcycle. Vehicles, when they stop, including motorcycles, bicycles, cars, trucks, their braking distance, how far it takes for their vehicle to stop, is a quadratic, which means it's a parabola. So we're going to watch the video. You don't have to. We're just going to collect data from the video, and then I'm going to use Desmos. And it's nothing that you have to know, but I just wanted to show you a real life application of a parabola that you might be in the real world. Because I'm sure you have ridden in a car or a truck or a bus or a train or airplane or a motorcycle or scooter, bicycle, any of those. So just kind of watch the video. We're just watching it to get the the data out of it, and that's it. I hope you have a nice day. Bye.